Hello, let's solve pips. It's time to place some dominoes. We've got 2 by Ian, 1 by Rodolfo today. Let's try the easy puzzle. Let's start solving. Okay, we need 2 of something over on the left here. It could be 3s or 5s. We need a 5 that goes into something that there are 3 of, which means it'll be this 3. So it's the only thing that works there, which means we put a double 3 here, which means we can put our double 5 over here. Now we need less than 1 is 0, so that goes here. We finish the 4 with the 3, and that's the easy puzzle. Great. Let's move on to medium. Okay, we need a 2. Well, we need 2 2s here that connect to things. So this 2 goes across. So this 2 connects to greater than 5, which is only a 6. So that is correct. We also need our only other 2 goes into the 8, which means a 5 comes out of it. We also have less than 1, which is a 0 pointing into nothing. But we do need a 5 here. We only have 1 5. And it looks like our 4-sized equivalence region will be either 3s or 4s. So this 5 3, well, no, it's 3s. It can't point up because that would block the other missing domino. So it goes this way, which means our 3s are at the top, which means they go here. No, wait, that's wrong. Sorry, that's incorrect. It means our it goes here, sorry, that's where it goes, in order to allow room for this domino. And then this one points this way, our last 3. Then less than 2 must be double 0. Our equivalences are 2 4s. And finally, our other less than 0, well, our 1 less than 1 goes there. And that was the medium puzzle. All right, let's try hard. I really hope that this is not as challenging as, whoa! Well, Rodolfo does have consistently interesting ideas. Okay, fascinating. So I guess we start in one of the corners. We have to figure out which of these corners is going to tell us something. So the upper left is either 0 4 or 0 2. I bet we'll have both. We do have both. In the lower left, 0 4 0 1. Yes. In the lower right, 4 3 4 1. Yes. And in the top, 3 1 3 4. Yeah. Okay. So I'm not surprised that we had all of those. But what I'm not sure about is how to disambiguate. That's really interesting. Do we have a double 4? We do. Do we have a double 2? We do. Wow. Okay, how do we get started with this? What do we have the most of, or what the least of, maybe? What's the most constrained? There are 30 cells in total. We have 6 zeros. 6 ones. Are we going to have 6 of everything? I bet we are. Yeah, we are. We are. We're going to have 6 of everything because we only have 5 unique digits, 0, 1, 2, 3, and 4. So each of them appears 6 times. How do we get started with this? I mean, this does feel like a case where maybe we just put in the first possible thing. Now, putting the 0 4 in there means we cannot put a 0 4 in down here. So I think this is all going to sort of cascade, which means this down here would have to be a 0 1. So either this is all going to fail, or it'll just end up being correct the whole way through, presumably. Although maybe it won't cascade. Well, so this 0 4 cannot be possible, which means now the 4 has to connect to a 3. This is so interesting. So based on that one decision, I think lots of things will cascade, but maybe not everything. I'm not sure. It's hard to tell yet. Oh, interesting. And either way, we've got 2 we've got 2 connecting to 2 here, which is possible, but might not have been required if we wouldn't have been required, I think, if this 0 was connecting vertically to the 4. Oh, right. Oh, I see. Oh, this is interesting. The 0 4 gets used over here either way. Right. Sorry. I'm going to start this over and look at something I just noticed. So this 0 4 can go here, but it could also go here. And I think it needs to go in one of those 2 places, because if it went in neither of them, let's see, if it did go in neither of them, I think it breaks, but let's just see. I'm curious to see if it does. If it goes in neither of them, that means this one's 0, 2, And this would be 0, 1 to avoid either of those situations. Now, does this break anything if we do this? Maybe it doesn't. Maybe this is actually fine. I can't quite tell. Maybe that's fine. Yeah, I don't necessarily see a problem just yet. This would still mean we need a double 2 in one of those, but that's... I don't know if that means anything yet. Interesting. What does that mean over here? We've used 0, 1, and 0, 2. So this 0 cannot connect to 0, 1, so it needs to be 0, 3 or 0, 0. This 0, 1 cannot connect, which means this... Oh. So we can't put a 1, 0 going up or across, which means it has to go down to the 1, 4. And this is very intriguing. I'm just not sure how to know which way is correct. Now, does that tell me anything? Again, we've used our 0, 1, so this can't go across. So it could be 0, 3 or double 0. Does now having used the 4, 1 cause any problems? Not really problems per se. Right. Okay. So I don't think it is obviously true that we need to use the 0, 4 over there. We do have to use it somewhere, though. So maybe that's what to think about. Well, it could be right here. It could be right there, near these other cases. Yeah. Or over here. Or even right here. Yikes. How on earth does this work? Maybe I should just try one and go with it. Just see what happens. I'm just curious. So that's a 0, 4. That's a 0, 1. So we can't use the 4, 0 pointing up. So now we have to use the 4, 3 pointing across. All of this was predicated. The reason I chose this first is because it's like the first possibility reading left to right in ordinary order is filling that domino with a 0, 4. I think that'll make it easier for me to remember. That's what I started with. Anyway, we can't put the 4, 0 vertically there, so we need a 4, 3, which we, of course, do have. And we need a double 2 in one direction in this corner, but we don't know which. Oh, right. But the fact that we need a 2, 2 there means we can't put a 2, 2 here, which means we must put a 2, 0 down. And we can't put a 3, 4 here because we've used one, so now we need a 3, 2 pointing up. And it's so interesting how this works. So something else is going to have to be constrained, right? But I haven't figured out what it is yet. Is it 3, 2? Yeah, 3, 2 can't go here, which means it must be 3, 1 pointing down. So we can't put 3, 1 there. So this needs to be 3, 2, which I think we have also already used, or 3, 4. Oh, which we can't. So I think we now can't put anything in this coming off of this 3. It can't go up to a 3, 2. We've used that. It can't go across to a 3, 4. We've used that. And it can't go... Can it go down to a 3, 1? No, we've used that as well. Right, so this does break. But I'm not quite sure what I've learned from it. I guess what I've learned is we know that this 0 can't go across, which means the 0 must go down to the 0, 2. I think that's what that means. So that has to go there. Is that enough to be very useful? Is there a place where now having put that in causes a problem? In other words, a 2 that can no longer connect to a 0 or a 0 that can no longer connect to a 2. I don't immediately see why that is a huge problem. But I think it's correct. How interesting this is. Yeah, I can't see what that specifically is doing that is useful. This is a very intriguing puzzle. I just don't understand how to get started with it. I'm sure I'm missing some overarching insight here. If we put 4, 3 here, that would mean we couldn't put it down there, which would mean this would have to be 4, 1. I like the way it cascades. I just can't see far enough ahead to be able to make immediate determinations about it. This, oh, and now this can't be 4, 3 this way, which means this needs to go across 3, 1. Now this would need to be 2, 3 because it's just physically constrained. Now, oh, now look, we've got 2 potential 4 zeros in a row adjacent to one another, and we can't repeat the same domino. We won't have 2 of them, which means this needs to be 4, 4 across in this world anyway, which means this now needs to be double 0 for physically constrained reasons. Which means this has to be 1, 4 or 1, 1, but we've already used the 1, 4. So this needs to be double 1s. We're using all of our doubles, which means this now needs to be 0, 3. It's all still working. It's not breaking yet, which means this needs to be 2, 2. Which means this needs to be 0, 1 or 0, 4, but we still have both of those. This is 2, 3 or 2, 4. I don't think we can use 2, 3 anymore. Yes, we've used it. So this is 2, 4. Which means this must be 1, 2, which we do still have. It feels so precarious. I feel like I'm playing Jenga, just waiting for it to fall. We don't have a 3, 0, so we need a 3, 3. This works. 0, 4, 0, 1. Wow. Right. Someone please let me know. What is the sort of brilliant insight that makes this necessarily this way? Or was there even another way to complete it? There may have been. I got it by just sort of looking at places that clearly constrained other areas and therefore creating a cascading series of necessary placements. But there might have been a more elegant way to do it. I'm not sure what it was. But that was very intriguing, that's for sure. That was the Pips. Back tomorrow. Bye for now.